All right, here is problem 8.4.33T. This is using a confidence interval for proportions. The challenge with these is that we can't use the confidence dot T or confidence dot norm. We can't use that for proportions, so we actually have to do out all the math, and that kind of stinks. As always, I kind of start with what I know. So I know, let's see, what do I know? I know that the reported portion is 0.64. It says 64% of students enrolled at college. In 2013, a random sample of 320 individuals. So I know my sample size, N, is 320. And from this sample, 204 students were found to be enrolled in the college. So I'm going to call that X of 204. And I know that my confidence level is 0.9. And so the information I'm going to need to move forward is I'm going to have to find the sample proportion, which is just called P typically. And sample proportion P is just the number of successes X divided by the sample size N. So there's our sample proportion. I'm also going to need, what else do I need? I need my critical z-score. Okay, so first I'll find my alpha. My alpha is always 1 minus my confidence level, whoops, equals 1 minus the confidence level. And then my critical z, there's lots of ways to do it. Really what the critical z is the z-score, it's of the alpha divided by 2, okay? And because Excel is always, when we do that, it's going to show everything to the left, it's going to show a negative z-score. So the way I do it is I say this is the absolute value of norm.s.inv of the alpha divided by 2. So that's how I set it up for Excel to find my critical z. I'm just using the function norm.s.inverse of the alpha divided by 2. So that finds me the z-score of alpha divided by 2. And then you're doing the absolute value of that, so it's the positive side. Remember, this is a two-tailed test, right? So it's like a curve. And so when we're finding out that the z-score, it's going to be plus or minus a certain amount. And so I want to return the positive amount. That's why I use absolute value of norm.s.inverse of alpha divided by 2. So there's my critical z-score. Okay, so the first thing I need to do is find my standard error of the proportion. I'll call that SEP. And the formula for that is that it is the square root of P times 1 minus P divided by N. So that's my standard error of the proportion. And once I know my standard error of the proportion, I can find my my margin of error. Margin of error is just the critical z-score times the standard error of the proportion. And then once I have that, then I can find my lower confidence limit and my upper confidence limit. The lower confidence limit is just my P minus my margin of error. My upper confidence limit is the P plus the margin of error. And there we go. So now 0.593 and 0.682. Second question is, what's my margin of error? I've already figured that out. It's 0.044. And finally, then it's going to ask me to do some analysis. And so the reported proportion of 0.64 is squarely in the middle of my confidence interval. So because of this, I'm going to say because the confidence interval found in part A includes the reported proportion from 2007, this sample does not provide evidence that the proportion has changed since then. In other words, because we measured it now in 2007, let's see, yeah, at 64%, and we have a 90% confidence that it should be somewhere between 59.3% and 68.2%. So because it falls within that limit, it means we think that it hasn't really changed significantly since 2007. And that's it. So again, I hope that was helpful. And again, don't be afraid to reach out anytime you need help.